A long time ago, we believed that the entire universe revolved around our own little blue planet. It's called a geocentric model. We thought that the sun, the stars, and all those twinkling celestial bodies all danced around us. This theory was super popular in ancient Greece and Rome. Famous geniuses like Aristotle and Ptolemy really loved this idea. Why did people believe this in the first place? Well, first of all, we have a massive ego. Second of all, there were a couple of things that seemed to support it. For example, if you stand on Earth and look up at the sun, it seems like the sun is spinning around us once every day. The moon and the planets seem to be doing the same thing. The obvious conclusion is, oh, they're probably twirling around the Earth. Then there's the fact that Earth feels pretty steady when you're standing on it. It just doesn't feel like it's moving, you know? And because of this stability beneath our feet, people thought that the Earth was unmoving. But even back then, there were ancient Greek and Roman philosophers that were onto something cooler. They paired the geocentric model with the idea that Earth was actually a round ball floating in space, not a flat disk. They started connecting the dots. And after a while, astronomer and mathematician Aristarchus of Samos had a game-changing idea. He thought that the Earth might not be the center of everything. He proposed that everything revolved around the sun. Funny to think that back in the days, this idea was considered insane. That's why for a while, most people stuck to their geocentric views. It took us many centuries to finally accept the heliocentric model, where all the planets in our solar system revolve around the sun. This idea was brought to life by people like Copernicus, Galileo, and Kepler. This change wasn't easy for people. It was hard to let go of our space crown. But gradually, we came to terms with it. And by letting go of this idea, we discovered a whole new world. This journey led us to an astonishing realization. Not only we're not the center of the universe, we're nothing but a little speck in it. We're a microscopic dot, sprawling galaxy called the Milky Way. The discovery of the Milky Way started right from our own backyards. If you've ever gazed up at the stars on a clear night, you might have noticed a faint, luminescent band stretching. It's like a shimmering celestial ribbon woven with stars. That is our galaxy. It was named Milky Way because it looks like someone spilled milk on a road. It was perfectly depicted in the 90s by Voyager 1. NASA's spacecraft took a picture called the pale blue dot. That tiny little pixel that's almost impossible to see is our planet. The photo was taken from a chilling 3.7 billion miles away from the sun. On a universe scale, this distance is nothing. But for us, it's unimaginable. So when scientists discovered the Milky Way, they armed themselves with telescopes. Their goal was to map the uncharted territories of the night sky. And of course, to find our place in this gigantic world. To do that, first, we had to unlock the secrets of our galaxy's structure. Okay, so we can clearly see that it has some band-like formation. That probably means that our galaxy is not a big, round ball, like the planets and stars. In reality, it's more like a giant pancake, a flattened disk. And we can see that we're not above it, and not below it. We're right on the plate. The next step is to travel across the Milky Way to map it. There's a little problem, though. To do that, we'd have to traverse thousands of light years perpendicular to this pancake-like plane. Just to put things in perspective, think of Voyager 1, the one that took the pale blue dot picture. That spacecraft has been journeying through space for almost half a century. It left the solar system years ago. You know how many light years it traveled? 0.002. And how many light years is the Milky Way? 100,000. You get the picture. But the lack of fancy technology didn't stop us. In the 18th century, a bold astronomer named William Herschel decided to explore our galaxy. With nothing but a telescope, this Indiana Jones of astronomy started mapping the stars in the night sky. As a result, he discovered Uranus, more than 2,000 nebulas, and created the first map of the Milky Way that depicted it as a disk. The map wasn't super accurate, but still very impressive. Unfortunately, he didn't know about something called interstellar dust. It's like space fog that can block our view of stars in the center of the Milky Way. This dust made the central region of the Milky Way appear less crowded than it actually is. Now, let's go all the way to the 20th century. Henrietta Swan Leavitt, an American astronomer, was another curious stargazer. But she focused her attention on a special kind of star called Cepheid variables. These stars had a unique quirk. They pulsed, getting brighter and dimmer in a predictable pattern. Leavitt's job at the observatory was like being a librarian. She cataloged these special stars, and in doing so, she stumbled upon something incredible. A direct link between the brightness of these stars and the rate of their pulsations. This discovery is now known as Leavitt's law. It meant that by simply measuring how quickly these stars pulsed, astronomers could figure out how far away they were. These pulsating stars became the rulers for measuring distances. Before the 1920s, most scientists believed that our Milky Way was the only galaxy in the universe. But as telescopes improved, some astronomers started realizing that this isn't the case. We started finding more and more galaxies. But if the Milky Way was just one of many galaxies, where exactly were we within it? Meet the scientist named Harlow Shapley. Armed with a powerful telescope, Shapley turned his attention to globular clusters. These are tightly packed groups of ancient stars that gather together in spherical shapes. That's when he noticed something interesting. The oldest stars around us weren't scattered all over the canvas. They were clustered around the center of the Milky Way, and they were pointing in the direction of certain constellations like Sagittarius and Scorpius. It turns out that the origin of our galaxy began from the center. It was the heart of the Milky Way, and the most ancient guys were hanging out there, which means we're not even at the center of our own galaxy. It seems like our importance becomes less and less with each new discovery, huh? Anyway, Shapley found out that we were positioned somewhere on the outskirts of our galaxy. Shapley's calculations weren't perfectly accurate, but he got pretty close. Luckily, now we have very precise and cool tools. Since then, we've since pinpointed our precise location. We're located near a partial arm of the Milky Way called the Orion Arm. It's about 26,000 light-years from the heart of our galaxy. And that was the story of how we found out where we are in the Milky Way. You think our story is over? Oh, absolutely not. Meet Gaia, the European Space Agency's celestial cartographer. Launched in 2013, Gaia embarked on a daring mission. It has to map the Milky Way in unprecedented detail. Not just some rough map, but a photographer capturing every nuance of our galaxy. Gaia is piecing together the positions and motions of about 1 billion stars, and it's like 1% of the stars in the Milky Way. But even that tiny fraction is enough to create a masterpiece of cosmic cartography. What a grand journey it was. It led us from thinking Earth was the center of the universe to realizing we're less than a speck in the grand scheme of things. But what's more important is that this story shows humanity's drive to uncover the mysteries of the world. And there's always something new to explore. Discoveries just keep coming, so stay tuned and keep looking at the night sky.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.